Having pioneered a new process, the company now produces some 4,000 different shapes for customers who want accuracy, quality, and the least possible machining after casting. Always at the forefront of foundry technology, Precision Products adapts and evolves its processes to suit new products and new markets. To a form suitable to mould, it goes to the foundry a quarter of a mile away. This opened-out moulding box is being used to make a copy of a vintage car spanner. A release agent is applied so that it becomes non-stick. It's carefully cleaned to ensure a perfect reproduction, and the box sides are assembled to contour the mould for economy. A catalyst from the can is added to a casting solution in the rubber bowl, followed by a high-quality ceramic facing powder. This is mixed into a creamy slurry, which is then poured over the half patterns. As the mixture gels, a coarse ceramic grit is added, so that the facing will stick to the backing. The box is assembled, ready to put the backing in. The Shaw Process casting solution is a colloidal suspension of silica and alcohol. It is stable within a narrow pH band, and it forms a firm gel when an alkaline catalyst is added. A different ceramic powder is now added. Because it will not come into contact with the steel, it does not need to be of such high quality. Once the backing gel has formed, the box is taken apart. There's a short period while the gel is strengthening before the mould is lifted off for firing. This first firing will burn off the alcohol and any other unwanted volatiles. This is the critical stage. As the alcohol burns off, tiny cracks, microcrazing, appear in the mould. This is the key to the Shaw process. Seen under the microscope at very high magnification, this is what microcrazing looks like. In this ceramic jigsaw, the size of the cracks is critical. They must be small enough to stop metal penetration, yet large enough to take up the expansion of the ceramic particles at intense heat. This structure gives the process its great accuracies and the quality finish of the component. Elsewhere in the plant, the quality inspector has got an order for castings, which need to be traceable for the whole of their lives. Before that order goes to production, he issues an individual serial number, which will stay with each casting for good. Here, a pattern for the top half of a large impeller is receiving its serial number, always issued by the quality inspector, which will be imprinted on the casting. This is one of the largest impellers made at Alstom, but the process differs hardly at all from, say, the small spanner. A bucket of high-quality facing material will go into the box first, and the mould will be built up until the part which will form the holes for the pouring header can be put on. An important factor in Precision Products' success is the continuity of its workforce. These two ladies were among the original recruits in the 1940s, and more than a fifth of the employees have over 20 years' experience. It's very much a family firm too, with second and even third generation employees. The inside shape is formed by silicon rubber, which will flex to allow core removal, but which returns accurately to its original form. In this case, the complete assembled core box is put on a turntable so that it can be rotated while the ceramic slurry is poured in. This ensures that the amount of trapped air can be kept to the minimum. Safety is the reason why the box is carefully clamped. The half mould is hardening now. It will be lifted off the pattern and taken over to the gas jets for firing. Mould weight limits the size of casting that can be made. Any increase in mould size presents difficult handling problems in a foundry which was designed and built for small castings. The final casting will weigh 80 pounds, about the top weight that can be handled at precision products. Back at the turntable, the core slurry has been mixed and is being poured in. This slurry is chemically treated so that it sets more slowly. The core box can be carefully filled, so avoiding air bubbles. The gel has formed and the core box can be opened. The gel is slightly flexible and that will help separation. All this work calls not only for strength, but for great care and conscientiousness by the staff, who are continually watching quality too. The grid will form a base for the firing process. Before firing, though, ceramic flash has to be removed. In the next shop, immediately before the foundry itself, moulds are prepared for their final baking. The moulds for small castings, after inspection, are assembled in groups or trees if possible. This is a convenient way of handling them as a batch in the foundry. They have a common runner which feeds each casting, and they are clamped to hold them together while an outer coating of slurry is applied. When the coating is set, the trees will hold together without the clamps. The first bake is at a low temperature to harden the slurry. A variety of stacks is assembled for baking. The runner cups have been fitted and coated with a ceramic paint, ready for the final bake-out in the foundry. The impeller, which was being moulded from patterns earlier, is assembled here. The core for the internal shape is placed on the bottom mould. The top half will cover both of these. Because of the accuracy of the mould location, the parts fit together exactly. There is very little danger of mismatch. It is very rare with this process. The part number and identification serial number are chalked on. Special chalk is used to withstand the 1000 degrees Celsius temperature of the final bake. At the end of each day, the ovens are loaded up with the moulds for casting the following day. They are loaded in the reverse order to casting, and they're baked overnight to 950 to 1000 degrees Celsius. This baking is to remove all the remaining alcohol and organic materials. The mould must be totally inert, so there is no reaction with high temperature molten metal. For some steels, Precision products start with a low carbon scrap, to which is added alloying materials such as nickel, ferrochrome and ferromanganese as required. For other steels, the company buys in pre-cast ingots so that it uses pre-analyzed steel for each melt. The accuracy of composition is checked by spectrographic analysis. All metals are checked by analyzer as soon as possible after they are poured. The spectrographic analyzer is the latest addition to Precision Products' quality control methods. Morning, and the moulds come out of the oven for the day's pour. There are 3 furnaces of 60 pounds capacity, 80 pounds, and the largest is a twin pot of 120 pounds and 300 pounds. Melts take 30 to 40 minutes for the smaller pots, more than an hour for the largest, and they go on throughout the day. Melt details and serial numbers are always recorded. Every part is traceable should there be a fault. Once they've cooled, the castings are knocked out in the usual way. Headers and risers are cut off, and any flash which has formed. Other surplus material is removed by hand grinding. Some of the ceramic core can be removed by blasting, the more tenacious by wire rope rotated at high speed. Shot blasting is the last operation before inspection.
Gordon, have we got rid of this problem with the thin shroud?
Yes, we seem to have, Roger.
Quality Inspector Gordon Cameron is Managing Director Roger Ball's first call each day. If a visible fault has slipped through, this is where it must be detected.
About 20 thou there. 20 there. So it's within drawing spec.
So it's not dipping in the back.
No, it doesn't seem to be, no. And the shroud is flat as it should be. Yes.
This is a sample from a new impeller pattern which is being checked. It is dye penetrant tested for micro faults invisible to the naked eye. When needed, X-ray or gamma radiography are available. After the dye is wiped off, a white developer will be sprayed on. It will turn red if any dye penetrant is left in a micro fault. The casting is clear and the product method is approved for the full order. This casting is a customer's reject and is being retested to discover the severity of the fault, which showed up in final machining. The customer specified no repair in this case, or the company might have salvaged it. A record is kept of the reject and it is logged against its original serial number. Roger Ball will then check that number through the various stages of production to try to establish the cause of the fault. Precision Products prides itself on meeting delivery dates, along with all other steps it takes to satisfy its customers. Personal service is a reality. In an emergency, castings have been hand-carried to an overseas customer within 24 hours of clearing inspection. The company avoids excessive claims about tolerances, but small dimensions are usually held to within plus or minus 7 thou. On larger castings, plus or minus 15 thou might be more realistic. Each casting must be treated on its merits.